About this in positive and negative. So we have a transformer that's powering that DC motor. We have a voltage generator that's giving power to the relay. So to make this work, you need 3 volts. That's why it's 2.8. Now this thing is being fed by the wall, and you're getting 110 volts in AC and coming out with 26 volts DC. Now the red is the AC coming in. It doesn't matter if you have neutral or hot or neutral, just as long as it's connected. Then you have a switch that's right here. And so basically right now it's taking the hot, going to the switch. Then the switch runs and then it allows the hot to get into the transformer. So the transformer power supply is done. Then the transformer comes out with 12 volts. No, with 26 volts. And then we decided to say, which side is, this is negative?
Yes.
Negative. So the yellow wire that's connected to the white wire is negative. The yellow wire that's connected to the red wire is positive. All right. So everything here is positive. Everything on this side, on the right side, is negative. So as you can see, let's follow the positive. So there's your positive. It goes into this, it's called the diode bridge, which is right here. So the diode bridge, the middle legs are
I'm looking for like a normal diode.
AC, and the outside legs are DC. So it goes into there, and then this positive is now going to over here. But before it gets over here, we also connect the positive to the positive of the capacitor, and the negative capacitor goes on the negative side, and that makes the motor run smoother. It basically, the capacitor fills up with electricity and holds it, and every time that thing's asking for power, it gives it. So that's what the capacitor is doing, and is measured. And this thing is asking me for a 2.2 microfarad, but this is a much more bigger than a 2.2 microfarad capacitor. So moving forward, we have a capacitor system, and now the positive is going into here. This blue wire carries a positive into the relay. The relay, when this thing giving it 3 volts, will connect these two together. Now then the 26 volts is traveling across here. Then from there, we connect it to the motor. So this is the motor, and it'll go right there. But before we connect it, let's measure the voltage that's in this wire. So go ahead and put right this side. So that's positive, and that's negative. You see positive 46. Go ahead and reverse it. You'll see negative 46. Hold it right there. So that's negative 46. So this is because we reversed it. So now we know that this is negative because I have an opposite number. So now, okay, so we're good there. So now we're going to connect our motor into the circuit board and make it work. And it runs. And now I'm going to turn this off, and it should stop, because there's no more power going to the transformer. Now I'm powering up the transformer, but if I turn off the controller, I don't give it 3 volts, then the relay will separate, and that thing doesn't get any more power. So watch this. Which one do you turn to make this smaller?
We only have like 3.
That one, go ahead and turn it. Make it to a smaller number. Voila. So he's at 1.3 volts, and that's not enough to make this relay work. So turn it up slowly until it actually works. Just real slow. 2.1 not working. 2.4 not working. 2. So it needed like 2.8 volts to work. Now the other question is, you can see how nice and smooth it's spinning. When I pull out the capacitor, you'll see that it will spin slower. Go ahead and pull out the capacitor.